and then go to one of the companies who have impressed me the most in the recent years. From New York, PLX is a company that you ever had the chance to see the coolest retroreflector ever. See what they can do. Itai, thank you very much for being with us this afternoon. Tell us how we can help you and how you can help us. The floor and the attention of everyone is yours.
Good morning here from New York. Tell me just if you hear me. Do you hear me? Well, okay, good. Good afternoon to the colleagues in Europe. Thank you so much for inviting me, Jose. Always a pleasure to see you and collaborate with Epic. You're doing a great job, specifically these days. Without further ado, I'll just start my presentation because I just have 6 minutes, if I'm not mistaken, Jose. My name is Itai Vishnia. I'm from PLX. We are in Long Island, New York. As the first slide emphasized, we are transforming space optics by integrating innovative monolithic optical system. A nice sentence, but in general, what we are specializing is light manipulation, the art of light manipulation in extremely high accuracy and harsh environments. So needless to say, space arena is one of our main presentation. We participate with many large space programs, but more so right now we see the interest of nanosats and LiDAR, whether it's space on ground, but these are where you can find our parts. So in general, light manipulation, how do we do this? Sub-arc second, through sub-arc second beam delivery system, beam folding and steering, and as well as spectroscopy in space, and all that under harsh environment. All of this beam shaping and folding is being done with a specific technology, which I'll introduce in a second. I just kind of want to emphasize, and that's strictly related to the EPIC arena and the friendly approach. This is essentially our business model, following EPIC approach, looking for constantly partnership of talent companies, small to large. We accustomed to work with both, and adding to our capabilities, and we'll work together. We do have we do have significant space heritage, which I'll introduce in a second. But when you push the limit, you really want to look for good partners. So talking about business model, we're dealing with optical assemblies through sub-integration and system integration, and you can see the following categories. In terms of what we've achieved, we go as low as 0.2 arc second. We are dealing with hollow optics, so as such, we are not limited with the spectral arena. We can cover the entire spectrum. Dealing with really harsh environment, you can see just an example of some shock and vibration that we've dealt with, but each one is really specific to the application. Some flavor as far as our space heritage. These are just the major programs that we dealt with. As you can see very clearly here, there is no specific CubeSat program. These are all small companies that we are not listed here, but through EPIC, thank you for the previous new space presentation that we've had. We actually collaborated already with a couple of companies, and right now things are kind of on hold till we open the economy and we can move forward. So we do have some exciting news as far as where we can fit in. CubeSat and free space optics are the biggest. And Jose, this is exactly what you like, what we can provide and what we need. I'll just summarize it here now quickly, and then I'll move to the next slide showing our technology. So miniaturization is what we do best with conventional, unconventional optics, whether it's freeform optics, whether it's conventional optics, integrating it together into a small CubeSat where cost is really an issue, and you don't have the voltage energy to warm parts, and you really need them to be accurate. That's where you can find our technology. For simple application, PLX can supply standard cuts, but the integration aspect is really where we can support the CubeSat, nanosat arena. In terms of free space optics, ground to satellite, inter-satellite links. When it comes to triangulation, there is a lot of cost saving associated with that, not just communication. Triangulation with retroreflector is easy done because the beam is reflected back to its source. This is just an example of some of the project that we participated in. This is a retroreflector combined of 3 silicon mirrors. One of them is MEMS. I'll jump quickly to introduce the technology, Monolithic Optical Structure Technology, with this short video. What you can see here is a lab setup of a Michelson interferometer. So spectroscopy in space is something that we've done quite a lot. This is the conventional approach, very sophisticated. Mechanical design can always be done, but the big challenge is how do you have it maintain its accuracy. Sub-arc second accuracy in space is meaningful because of the distance. So this is what I call the plug and play approach. You replace the very convoluted, very complex design, save significant amount of space, insert a block which is very rugged and integrated to the next level assembly properly, pre-aligned, and you achieve very high accuracy. So that can be scaled up significantly, scaled down significantly for the CubeSat. We've made parts that are like 2 millimeter in size, even assembly that are like 10 by 10 millimeters. We are definitely looking to stretch the limit, and I'll go back to this previous slide in terms of partners and where we can get some help and support. We are constantly investing in developing new material. We are trying to work with the existing materials that we have available to us, but we are definitely looking for partners that can push the limits together with us in lightweight materials that essentially are one, both for structural as well as for optical. So materials that can be polished, materials that can be used for structures and combined using the M.O.S.T technology that I presented here. This is again just to give you a flavor of the type of accuracies. The thermal dependency of this particular assembly that you see here is 0.115% per degree. Jose, do I have another minute or two, or no? So. Yeah. Okay. Quickly, just to explain how this technology is put together. Monolithic structures, invariant optics. So the invariant optics is the most important thing. Invariant optics is obviously based on hollow retroreflector. We are the pioneer of hollow retroreflector, and when you have hollow retroreflector inserted in the proper orientation, or in general, you build the monolithic assembly with the invariant approach in mind, then you can achieve the plug-and-play approach. You can see an example of lightweight optics in terms of the aerospace arena. Just some of the projects that we've participated. Tropospheric emission spectroscoper. This was a mission of 14 years, 2004 to 18. We put together all of the components and assemblies for the interferometer, for the FTIR spectrometer. All were made with beryllium, 1 arc second in accuracy back then. This is Tirvim with ESA. This is the Mars mission. This is still working, functioning. This is the retroreflector that we're inserted in the system. And currently we do have a LiDAR system, big LiDAR system, but can be scaled down. That this shows a telescope alignment. This is with the Atlas program. It's ISET-2, measuring ice sheets. I think that I'm done with my presentation. I'm just going to show you when you ask if you have any questions, just some. I see that you cut me off.
Thank you so much.
Sure.
It's always nice to hear again. Of course, miniaturization is one of the main goals for this new space technologies, and lighter, of course, and low power consumption. All this we will go through it today. So you know how it goes with Epic. So now you show us what you can do for them, and we need to know. So you show us what you can do, and we need to know what can they do for you, or what kind of collaboration are you open to?
Yeah, if I can share again my screen, I'll just go to that slide and we'll just
Sure.
um, what we are looking again is as far as what we can get from both from ESA is very clear guideline of the application and the specification that they want to achieve, because we cover pretty much everything, whether it's with ESA, whether it's with NASA. So that would be one ask from the entire community. Really pushing and trying to stretch the limit with lightweight materials. So there are a lot of methods that we invented here with lightweight optics, but we're definitely looking for more collaboration from the industry. We are talking about materials that are going to be user-friendly for cryogenic environment, material that would be user-friendly for optical performance. So I can give some ideas. Silicon carbide is considered to be old. We're looking for something that would be able to polish like aluminum, light, and yet integrate together with the monolithic optical structure technology.